Hello, this is Danica. Jordan is not with us today. He will be putting together our presentation, and I'm doing this homework 12 for our Monte Carlo class. Our problem prompt today is to consider the Box-Mueller generator using the sine formula only, that is, and it gives you this formula. Further suppose that R1 and R2 are obtained through a maximum period prime modulus generator, once again giving you these R values. For any j within the range of 1 to m minus 1, where a is 131 and m equals 2 to the 31st minus 1, we need to show that the largest positive value of x that can be generated is approximately 3.54 and that the largest negative value is approximately negative 3.21. And then in a random sample of 2 to the 30th such variates corresponding to the number of variates produced over the entire period of such a generator, we need to calculate the expected frequency of a random variates that take values greater than 3.54 and less than negative 3.21 respectively. So to do this, I'm going to show you how we got those values of x. We're going to do this in Word. So this x value at the very top here is where we have the sine function that I was talking about earlier, and we end up knowing that we want the greatest value of sine. It said we want the greatest period of sine, which is going to be pi over 2. So because of that, we can end up manipulating this formula down for that largest value of x, and then j over m is going to equal 4a. And when we plug in the smallest j value that also makes sine 1, it would come out to be this 3.54. Similarly, switching over to the negative value, in this case we want it to be negative 1. That's the largest negative value that we can make sine. So when we plug in this 3 pi over 2 for the largest negative value of x, we end up plugging it back into that x equation and getting negative 3.21. So with that, the next part of our little recording is to show you the random generator that we created. So here, let me pull down this code. So A, M, and N were all given to us in the prompt. A was 131, M is 2 to the 31st minus 1, and then N, it actually gave us 2 to the 30th. However, it's very long and difficult for MATLAB to be able to generate that many random variates, so we divided it by 16 so that MATLAB could actually get through the process, and then at the end we're going to multiply by 16 to even that out. H and L we determined from the Word document that I just showed you. And then FL and FH, this stands for the frequency of the low values and the frequency of the high values. So these are going to be how many times when we do this random generator are the values falling outside of that lower number, the negative 3.54 or 21, and then how many times it is higher than our higher value. So then once we go, so those are arrays counting up how many times that happens. And then in our for loop, what's happening here is we have a random variable that's being generated, R1 and R2 and X, those are all given to us from the prompt. So if the random generated number is less than our lower value, that negative 3 number, then we're going to count that it fell outside our lower bound. If x is greater than our higher value, then we're going to count in this frequency of high array that we had an occurrence where it was outside the higher bound. And then else we just put a 0 in for each occurrence. So then at the very end for our low and high values, that's the count, it's the sum of each of these arrays, and then we multiply it by 16 because we had divided n by 16 in the beginning. And then our ratio of low and ratio of high, this is just showing like how many times it falls outside divided by the number. And And when we do this, I'm not going to actually run it just because it does take MATLAB a little bit. So I'll show you the values that I ran previously. We got about 50,000 times where it was under the low value, and then about 139,000 times where it was over the high value, which sounds like a lot, but when you actually end up doing the ratio, these are very low percentages. So it looks like our random generator is pretty accurate, and we're happy with that. So thanks for joining us. Talk to